For my test replacement project, I'm going to focus on Unit 6, Simple Harmonic Motion, Wave Properties, and Sound. I'm going to do question number 6 from the Wave Basics practice problem. This question asks, a hiker shouts toward a vertical cliff which is 465 meters away. The echo is heard 2.75 seconds later. Question A, what is the speed of sound of the hiker's voice in air? B, the wavelength of the sound is 0.75 meters. What is its frequency? And C, what is the period of the wave? So I think it's first important to define what each of these are. So the speed is velocity, which is distance over time. So velocity equals distance over time, which equals meters per second as the units. And then we have the period, which is the time required to complete one cycle, and that is represented by the capital T, and it's generally measured in seconds. So the equation for this will be T equals 1 over frequency, and that would be 1 over seconds. And then we have frequency. Frequency is the number of cycles or oscillations completed per second, and that is measured in hertz, which is hertz or 1 over second. So the equation for this will be F, frequency, equals 1 over T, the period, which will equal 1 over seconds as the units. So, question number 6, the first question asks, what is the speed of sound of the hiker's voice in air? So, we know that the distance equals 465 meters. And we know that the time equals 2.75 seconds, which we understand fits into the velocity equation. So we would have velocity equals meters over seconds, which equals V equals 465 meters over 2.75 seconds. However, in the question, we know that we're talking about an echo, which means that this happens twice. So, in order to solve this first question, what is the speed of sound, we have to multiply the distance by 2, because it's going to happen twice. So when we solve this, we get 338 meters per second. That's because there's no multiplying on the numerator or the denominator, so we just have meters per second. Another way to solve this is if we did 465 meters over 2 minutes and 2.75 seconds divided by 2, which is 1.375 seconds, you'll get the same answer of 338 meters per second. And that is because we would be traveling that distance, but only in half the amount of time, because that will account for the echo that will be heard. So for question number B, letter B, we have the wavelength of the sound is 0.75 meters. What is its frequency? So for B, we know that they are asking for frequency, so we know that we'll be using 1 over T. And another way to use frequency, which would be better in this situation, is frequency equals V over wavelength, velocity over wavelength. And the reason that this equation would be better is because it's going to give us the same number for frequency as if we used this, but we already have the velocity, which is here, and they have given us the wavelength, which is 0.75 meters. So all we would have to do is plug in the frequency and the wavelength. So when we solve this, we have frequency equals 338 meters per second over wavelength 0.75 meters. And when we solve this, we get about 451. And to figure out our units, we have meters over seconds divided by meters over 1, which is also written as meters per second times 1 over meters. The meters cancel out and you're left with 1 over s. That is the same as this, which is 1 over seconds, so we know that that's correct and that our frequency is 451 1 over seconds. So for part C, we know that we're being asked the period of the wave. So again, the equation for period is T equals 1 over frequency. So I can write T equals 1 over frequency. We know, since question B asked us for the frequency, that the frequency is 451, 1 over s. That all we would have to do is plug in T equals 1 over 451, 1 over s, which would equal, for our units, we would have 1 over 1 divided by 1 over s, which again is equal to 1 over 1 times seconds over 1. The ones can cancel out and we're left with seconds, so we know that we have 1 over 451 seconds. Or that can also be written as hertz. Hertz. And that is question number 6 of the Wave Basics practice problems.